So today we are going to start a new chapter, that is chapter number 4. Chapter number 4, the name is that the motion in two dimensions. Motion in two dimension. Before that we have discussed about the motion in one dimension, that was the motion in a straight line, right? So today we will discuss about the motion in two dimension. The first topic of this chapter, that is the projectile motion. Projectile motion. If we talk about the motion in two dimension, what was the motion in one dimension? Suppose that this is a ball, we have thrown this ball upward and this will come downward, and so this is called the one dimension, right? This is called one dimension. But how a substance can move in the two dimension, so that we will discuss about in this chapter. First our topic is projectile motion. This is the best example of the motion in two dimension. Basically, what is projectile motion? It is a motion at a point, object thrown in Earth's field, in Earth's gravitational field, in Earth's gravitational field is known as projectile motion. It's known as projectile motion. What do you mean by that? Motion at a point, object is thrown. How a object is thrown? Like this. Suppose that this is a ball. This is thrown like this. But if we talk about the drop in motion one dimension, we have only talked about if a ball is dropped or something that is dropped, so that will be in the one dimension. If you're talking about the anything that we throw, so that will be counted in the motion in two dimension. That substance will be motion in two dimension. So motion at a point, object thrown in Earth's gravitational field is known as projectile motion. Suppose that here this is a surface, right? A man is standing on this surface and he is having one ball, and he throw this ball. Here is one basket and he throw this ball in this basket. So you can see this is, he throw this ball, this is motion in the throwing, you can see here. So the gravity of this ball will be downward, right? The gravity will be downward. Here the gravity will also be the downward, right? So he throw this ball in one, we can say with a velocity, that will be the initial velocity, right? So this motion, when motion at a point, object is thrown towards the earth gravitational field, this is thrown towards the earth gravitational field here, so that field is known as the projectile motion. That motion is known as a projectile motion. This is a ball thrown towards a point in the earth's gravitational field, so that is known as the projectile motion. If any substance, suppose that if any substance thrown in gravitational field except any other field or any external force act on it, so the motion by the point in which the substance is thrown towards the gravitational field except any other force or external force, so that is also called the projectile motion. Now we will see some examples, right? We have seen the throwing of the basketball, right? The ball that is thrown like this. Suppose that this is a man, and he throw this ball, this is a basket, suppose that this is a basket, and he throw this ball towards this basket, right? So this motion is called the projectile motion. After that, if we take one example, suppose that this is a surface. Suppose that this is same ball, right? The same ball is thrown here. It is thrown here. You can see here this is ball is thrown towards this. So this ball will make an angle theta that will be like this. It is moving, this ball is moving in the horizontal direction, that is the x, and it is also moving in the y direction, on the vertical direction, that is y, right? You can see here, if the ball is thrown upward, right, it is thrown upward, so that it is we call as a y direction, and it is thrown downward like this, so we count it as a x direction, which means it is moving in a both direction. It is moving in the x direction and it is also moving in the y direction, so that is called the motion in two dimension. That is the example of the projectile motion, a motion that conducted in the two direction. You can see here it is moving like this, it is moving like this, it is moving upward by the y direction, it is moving downward towards the x direction, so this is known as a projectile motion. Now you can see here gravitational forces occur, g downward, here g also downward, here g downward, in everywhere g will acceleration, which means acceleration of this ball will be downward. Here I am making another, that this is a surface and this is a wall, this is x, this is y, and this ball is thrown in this direction, there is angle of 55, and this is making an angle theta, right? So this is a x, this is a y, and this is moving with the initial velocity, right? Obviously this ball will move in the, this ball will come towards the highest point. This is the highest point of this ball, right? This is a point at the highest point. When the ball will come here, when it will reach here, the Vy will be 0. Here the Vy will be 0. What is Vy? That is this one, vertical direction, that in the vertical we can say velocity will be 0 here. Vy will be 0 at the highest point of the ball, it will be 0 here, but the Vx, it will be same as everywhere, it will be same as here. Suppose that this is a ball here, Vx will be same. If the ball is, suppose that this ball is here, right, the Vx will be same. That is a we can say horizontal velocity, it will be the same. So here you can see that Vx is 0, Vx is constant everywhere, Vx is constant everywhere, right? So the acceleration is 0. Acceleration, it is moving with a you can say uniform velocity, this ball in the x direction, so the acceleration will be 0 in the x direction, right? So you can see ax is equals to the 0, right? And v velocity, which means Vx is moving with a uniform velocity, it is moving the uniform velocity. And if we talk about the Vy, which is a y direction, here Vy is equals to 0, that is velocity is equals to the 0. But if we talk about the acceleration, here acceleration will be equals to the minus g. Why we are taking minus g? Because when we throw any object upward, that we will take the g as a minus g. This will be the minus. When we throw any object upward, we take the g as a minus, because it is we are throwing that object upward, so we will take as a minus g. So here we are done with the x axis and y axis. Now I will tell you some points, important points. What we have learned, that acceleration is in y direction. Acceleration is in y direction, that is a minus g, and in x direction there is no acceleration, that is equals to 0. Acceleration will be 0, in x direction, right? acceleration of particle at every point is g in vertical, right? In the vertical direction, that is the y direction. It is, we can say it is g, we are taking g, which is constant. And here air resistance is negligible. Air resistance is negligible. Earth does not exert any force in horizontal direction, which means, as I told, that acceleration in y direction is minus g. So Earth is exerting force in the vertical direction, but here one point is given, that Earth does not exerting any, we can say, force in horizontal direction. If it's not any exerting any force in horizontal direction, so as I told, that acceleration will be 0 and the velocity will be the constant, and it will move in the uniform velocity. So here Earth does not exerting any force in the horizontal direction, but it is exerting in a force in the y direction. So that was the point. Acceleration will be only in y direction, not in the x direction, but the motion will be in both direction. Obviously the motion will be in both direction. Acceleration will be in both direction, but the we can say acceleration will only in the y direction. So that was a introduction to the projectile motion.